Hello everyone, welcome to my class. Today I am going to teach you a name reaction that's called Etard reaction. This is the method for the preparation of benzaldehyde, aromatic aldehyde preparation. Now the main reaction. This is the main reaction. In Etard reaction, we take hydrocarbons as a starting material and chromyl chloride as a chromyl chloride as a oxidizing agent in the presence of non-polar solvent CCl2 or CCl4. Further, I will tell you why we are using this solvent, but first we focus on this main reaction. If this is toluene hydrocarbon, then the IPSC name of this is methyl benzene. Either we can say toluene or methyl benzene. If toluene react with chromyl chloride, then a highly unstable product will form, and the structure of that product is this: OCrOH. This is a brown color highly unstable compound. So it is highly unstable, that means it is not a stable product or not. It is not our desired product. If hydrolysis take place, hence addition of water molecule, then benzaldehyde form. Wait a minute. Plus 2 molecule of this 2CrOH twice Cl2. In this case, we take hydrocarbon as a starting material, and this is oxidizing agent, and this is non-polar solvent, and the name of this compound is chromyl chloride. And this is non-polar solvent. Either we take CCl2 or CCl4. We take non-polar solvent, especially we take non-polar solvent because chromyl chloride is insoluble in these solvents. This is a brown color unstable compound, which is highly unstable. Here the partial oxidation takes place. Partial oxidation, because if there is a complete oxidation, then toluene will completely oxidized into carboxylic acid. This is a mild oxidizing agent. If we take a strong oxidizing agent like KMnO4, then toluene completely oxidized into benzoic acid. That means we are not the complete oxidation because we are not taking the strong oxidizing agent. This is very strong oxidizing agent, but this is mild oxidizing agent. Now come to mechanism. This is the structure of toluene. Now we draw the structure of chromyl chloride. Here we take 2 molecules of chromyl chloride. This is the structure of chromyl chloride, CrO2Cl2, 1 molecule. Now we make another molecule. This is the structure of chromyl chloride. Here homolytic cleavage take place both the atoms withdraw their electron. Here also the homolytic cleavage takes place. So this hydrogen is free and this hydrogen go and bind with this oxygen, and the valency of carbon is 4. That means carbon has tendency to form 4 bond, but if this bond will break, then it has tendency to form 1 bond. So this carbon go and bind with this oxygen, but before going to binding, here also homolytic cleavage takes place. So this carbon go and bind with this. Similarly, same condition here repeated. Here also homolytic cleavage and there also homolytic cleavage, and this bond will also break, and this hydrogen bind with this carbon, and the carbon has a 1 free bond, so this will bind with this. Now see the whole structure. We draw the brown color stable compound. First we take this compound and this carbon and this hydrogen, because this hydrogen is protected. Now this carbon bind with this oxygen. So see, with O, and oxygen bind with chromium with single bond. So Cr and chromium bind with oxygen, and this oxygen will bind with this hydrogen. So here you can write OH and then Cl2. If we see this group, then this carbon is also bind with this oxygen, and oxygen will bind with chromium with single bond, and this chromium will bind with oxygen, and the oxygen will bind with hydrogen. So OH and then remaining Cl2. This is the brown color compound which is highly unstable. So hydrolysis takes place. Hydrolysis means addition of water molecule in the presence of acidic medium. Now this oxygen, this complete group withdraw electron from the carbon and leave the group. Now if this oxygen take his electron, completely take the electron from here, then there is loss of this carbon and partial charge formation, and the oxygen shifted their bond between the carbon and oxygen, and this group also leave. Now the product is C double bond OH. This is benzaldehyde, and the byproduct is CrOHCl2. If this group leave with the electron, that means it has negative charge. Then the negative charge will bind with this oxygen and form CrOH and again OH. So OH twice and Cl2. And here this chromium loses its electron, so there is the formation of positive charge, and positive charge bind with this negative charge, and also there is already there is one OH, and this one H bind and to form OH2, and then CrOH twice plus Cl2, means 2 molecule of CrOH twice Cl2. This is the complete Etard reaction. This is the mechanism of Etard reaction. This is benzaldehyde. I hope you guys will understand. Now that's all.